We're going to factor these next problems using difference of squares, but these are ones that we notice now have a fourth power, and these are actually ones that are going to require factoring more than once. Okay, so again, the word completely usually means there might be some more things we have to do to that. So let's first start by writing this as squares. Okay, so we want to write the first one as a square. Now it's x to the fourth power. Now the way that we're going to do this is that's the same thing as x squared squared. If you raise a power to another power, you're actually multiplying exponents when you do that. And so that would be the way to write this as a square, x squared, and that's being squared. Now next, 625, that can be written as 25 squared. So now if I want to do the difference of squares, a plus b, a minus b, we're going to do that. The a is x squared and the b is going to be 25. So we're going to do x squared plus 25, x squared minus 25. Now, we're going to look to see if there's any other factoring we can do. And if we look at that, we'll notice that the second one, that can be factored also using the difference of squares formula. Now, the first one can't because there's a plus there. But because there's a minus, that one you are able to factor. So we're going to do x squared plus 25 here. And this one, 25 can be written as 5 squared. So we have x plus 5 and x minus 5. That now would be fully factored because we're able to factor that x squared minus 25 again. So we really factored twice on this problem. Okay, so let's do the same thing for the next one. Okay, so the next example we have here is another one that we want to write as a quantity squared. Now, 36 can be written as 6 squared. And then, of course, we also have x squared as well on that one. And then we have 49 can be written as a 7 squared. Well, this one, we can put that together and do 6x squared, and all that is quantity squared. Because when you square everything inside the parentheses, you'd have to square square the 6, and then square the x squared. So if we square both of those, we would get 36x to the 4th, so we know we did that correctly. Now we want to use the difference of squares formula. Okay, so difference of squares, we have 6x squared plus 7, 6x squared minus 7. So now we have that. Now what makes this problem different from the problem we did before is that if you notice on that, we don't have anything else that is perfect squares on this. In other words, the 6 and the 7 are not perfect squares. So this is not the same as the previous problem we did with the 25 because there's nothing more that we can do. So in fact, this is actually factored completely. 6x squared plus 7 and 6x squared minus 7 as far as we can go. All right, now let's do this last one down here. We've got the x to the 4th again, as we've done before. That can be written as x squared squared. Then this one, we want to write that. So this is going to be 100 squared. 100 times 100 is going to give you 4 zeros, which is what we have here. So now we have this. All right, so now we can write this out as x squared plus 100, x squared minus 100. We see here again that this second one, there's a 1 in front of the x squared, so we can write that as x squared, and then this is going to be written as 10 squared. So this is one where we can do factoring one more time. So the second one, we're going to expand this. We can do x plus 10 and x minus 10. And that right there would be considered fully factored. So again, this is another one we were able to factor twice because once we factored the first time using difference of squares, we see here that x squared minus 100, that could also be factored using difference of squares.